Hello there. This is a group project of Group 11 of the Engineering Ethics class of the National University of Malaysia, and we are tasked with the responsibility to have a discussion on the Mihama nuclear power plant accident. This is the list of group members: George M. Dukle. I'm the voice caster, and followed by Mohammed Azri bin Ghazali and Ahmad Zam Naquidin bin Mod Nazam and Noor Adila Benti Nazuddin. So basically, the Mihama power plant was located in Japan, 320 kilometers west of Tokyo in Japan. It was operated by Kansai Electric Company, and it was situated in the Fukui province. This is a schematic diagram of a nuclear power plant, and as you can see, there are lots of processes involved, and our focus will be right here where the rupture occurred in the nuclear power plant at Mihama Island. This is a picture of the power plant, nuclear power plant, and this power plant was the first nuclear reactor to generate electricity commercially in Japan, and that was in 1970. From a top view, this is a picture of the incident occurrence. On Monday, 9th of August 2004, fatal accident occurred, and it led to the death of 4 workers, and it injured 7 other workers terribly. And how did this happen? Now, from expert advice, the power plant management was advised 9 months before the incident that, hey, this power plant needs inspection, and by this you guys will avoid a lot of stuff. But the warning was ignored, which led to this accident. In the nuclear power plant, the high pressure water is used to carry heat from the reactor core to the heat exchanger, where it heat turns water of the secondary cooling cycle into steam, which drives the power turbine. The steam is condensated and fed back into the heat exchanger, just like a power cycle, and of course it is. But something to a point that the existing regulations did not explicitly require the company to check the secondary cooling cycle steam pipe of the nuclear power stations. Some causes of this conflict and happenings boils down to the maintenance. On a day when maintenance was being carried out, there was the accident of the rupture of the pipe, the bursting steam pipe, and it was situated in the non-radioactive part of the reactor, and that was quite lucky. In 27 years, that's quite long, 27 years of operation, there was this pipe that's 56 centimeter in diameter. It had a thickness of 10 millimeter, and it corroded down to 1.4 millimeter, which was against the regulations, and regulation says that it must be 1.7 millimeter and then changed. This is a picture of an example of a ruptured pipe. Just some notes on the Mihama nuclear power plant. It is an 826 megawatt electricity provider in the 3-loop West Austin type pressurized water reactor. which has been in service since 1976. The pipe rupture occurred at loop A, the condensate system between the four-phase water heater and the deaerator downstream of the orifice for measuring the single phase of water. Some highlights of this nuclear reactor power plant, because of the heat exchanger separating the two cooling cycles water in the secondary cycle, and the steam turbine were not radioactively contaminated because the pipe was not situated in a radioactively contaminated position. But in between 1998 and 2003, Capco replaced carbon steel pipes in two other power stations. That was Takahama Nuclear Power Station at number 3 and Oi Nuclear Power Plant at number 1, and they were replaced with stainless steel pipe. Inspection had revealed that the original pipes had worn so thin they wouldn't even last for a year, and that was a smart step to take. Here we see a schematic diagram also of a pipe, and the working fluid has a flow here towards the left, and at this point you can see clearly there is a turbulence and you can see a flow back. So with this turbulence you notice that the fluid produces friction between the pipes and the walls of the fluid, which produce some erosion on the pipe, and with the fluid at a very high pressure there will be some bursting of the pipe if the pipe layer is too thin, and here you can see a fracture here. Now with the ethics theory, some residents, like all of the residents, I'm sure they are experiencing a growing frustration and instability due to the nuclear crisis, though it has been some years, but they are unable to return to the normal life after this disaster. Chemical components of radioactive waste may lead to cancer, and for sure if radioactive waste are exposed to the environment they will lead to cancer once it's ingested or inhaled by the inhabitants. So it had raised some major concern when it comes to safety as it relates to the nuclear construction program all over the world. They would have avoided most of these happenings if some basic measures were in place, such as the carry on maintenance as often as possible, and solving high-risk problems as soon as possible. These are preventive maintenance, and all regulations about high maintenance need to be more strict. All the process during machine operating should be supervised. All the machine must be tested to ensure safe operating conditions. And even these guys down here, I'm sure they are well safe and carry on some safety measures. From this situation we have drawn some lessons. Firstly is the maintenance and safety in nuclear power station. They must be given high priority. Materials used always should be checked for safety conditions in order to avoid unexpected accident. Monitoring and regular testing must be carried out in order to detect or predict equipment or operators failure. Never postpone or ignore inspection, most especially when it comes to the tube as from the incident. The inspection must be particularly detailed, and safety standards must be upheld. They must be imposed and progressively tightened. The operation should be handled with precaution. The employer and workers must extremely must be extremely vigilant and prudent. They must create and strengthen a culture of safety and meticulously respect the rules. And if you don't respect the rules, for example, if you're carrying on maintenance and you're not abiding by safety measures, you'll be in danger. And they must also be able to limit the damage of the prevention. With conclusion, we've come to a conclusion of this catastrophic nuclear power plant incident wouldn't have occurred because it wouldn't have occurred if they have taken some measures. But accordingly, these employers and businessmen, they have prioritized, let's say, they have prioritized profit over safety. And even if some measures were taken, once they are concerned with how nuclear power plants are going to improve and how more profits going to be generated, and they don't take seriously the safety measures, it won't work. And in this instance, serious penalty must be given. So there are a few recommendations here from my group, and this recommendation boils down to all pipes where serious water thinning would occur and cause damage and danger, they must be inspected, they must be checked. You must shut down the reactor before operation of inspection proceeds. Do not abandon something called a liable defect standard right here, liable defect standards, despite the fact that cracks have been discovered and also close down all of the old reactors. You must have high quality design and construction. And all of these points, they can be considered though, but if these were done, as long as the power companies prioritize profit over safety, and also the regulators they are more committed to ensuring the future of nuclear energy than ensuring safety, it still wouldn't be enough. These can be summed up to three major points, that is prevention, monitoring, and action. You prevent and you monitor and you take action on expected accident, or to monitor and prevent, you must take action, and also if you want to prevent, you must monitor and take action. And you can check out these references from my group. You can check out YouTube of the incident, you check out Joey and Wikipedia also on the Mihama nuclear power plant disaster. Thank you for watching and thank you for listening. We're group 11. Thank you very much.